Page 3, we're getting there. 28 and 29, I'm actually going to show you how to do this two different ways here. We have this identity, all right? We have this tangent function, and we talked about how the tangent is just the sine divided by the cosine, right? So they're telling us right now, they're saying, hey, the sine of theta, all right, whatever theta is, I don't know what the angle is specifically. I just know that the sine of theta is 7/13. And I also know that the cosine of theta is 2 square root of 30/13. All right. Now, what I can do is I can take both of those and I can divide them. All right. So I can say the sine of theta, I'm going to try to color code this here, divided by the cosine of theta. Right, that is just going to be equal to, we have 7/13 on top, right? That is, we're just, swapping out, instead of saying sine theta, we're saying 7/13. And then on the bottom, we're saying 2 square root of 30/13. All right. This is kind of the algebraic way to show things. Now, we don't like, in algebra and in math, we don't like dividing fractions inside of fractions. That makes things a little bit messy, so we clean it up a little bit. So the way around this is you take that bottom one, and you're going to flip it upside down. All right, so that 2 squared of 30/13, that turns into 13 over 2 square root of 30, right? You take that bottom fraction, flip it upside down, and then we multiply it with the top. Right now, when you do that, notice how the 13s on top and bottom, you can kind of cross cancel those out. And then whenever you multiply fractions, go straight across. So we have 7/2 times the square root of 30. Right? And now we're almost done. The last thing we have to do is multiply or rationalize that denominator. All right, so I'm going to go ahead and just skip that. I'll do that in one go. We're going to have 7 times, you know what? No, I'm not. We're going to have 7 square root of 30 all over 2, and then 7 square root of 30, square root of 30 again. All right, so that's what it would look like. You multiply the top and the bottom by that square root of 30. So now the denominator turns into 2 times regular 30. All right, and 2 times normal 30 is 60. So we got 7 square root of 30 all over 60. That is what your denominator is going to look like here. So, all right, so your answer on this one is 7 square root of 30 all over 60. All right, now on the next one, again, we want to use this trig identity. The tangent is the sine over the cosine, but notice how they only give us the cosine. This is the cosecant. I don't want that. All right, that is not very useful. So instead, I'm going to write that in as sine, because we know the cosecant of anything is just 1 over the sine. It's the reciprocal. All right, to get the reciprocal of a fraction, flip it upside down. So we can say the sine of theta, come on, the sine of theta equals 5/12. All right, so we got the sine over the cosine. I forgot my thetas. Sine of theta over cosine of theta, plug in what you know. We got 5/12 equals the cosine, which, oh boy, we got square root of 119 all over 12. All right, kind of an ugly number, but that's okay. So you got 5/12 times 12 over square root of 119. All right. And just like on the last one, the 12's canceled. So you're left with 5 over square root of 119. Right. And we can fix this. We got 5 square root of 119 on top, all divided by a normal 119 on the bottom. All right, and that's how we'll do this type of problem here. Now let me show you a second way. All right, let's look at this first one. Think about it, it's all trig stuff. All right, trig is literally, trigonometry means the study of triangles, I think. All right, so I'm going to draw a triangle. It does not matter where you put the theta, right? All right, whenever you're making your picture, put it wherever you want, as long as it's not on the right angle. That one needs to be there. And I'm just going to put it in the bottom here. Now, they're telling us, all right, the sine of beta. Sine is the opposite over the hypotenuse, right? Here is your opposite. That's 7, right? The hypotenuse is 13, right? That's literally just using the definition of sine, all right? Now, the cosine. Cosine is the adjacent over the hypotenuse. So downstairs, we have 2 square root of 30, and then the hypotenuse is still 13. Right? They're asking us for the tangent. The tangent is just 7 over 2 square root of 30, right? It's the opposite over the adjacent. So you can say the tangent of theta is equal to 7 over 2 square root of 30. And again, rationalizing this, we got 7 square root of 30 all over 2 times normal 30, which gives us 7 square root of 30 all over 60, right? So notice that's the same exact thing we got when we did it the algebraic way, all right? Now, which one's better? I don't know. This is a half a dozen. This one is, I don't know, 6. It's the same thing. I don't, there's one easier than the other. I tend to like the algebraic way more, but if you're more of the visual people, you like drawing pictures and labeling stuff, then by all means, do this method. It does not matter. Same thing is going to work on this one over here. All right. But let's see here. Let's finish this off. Solving right triangles. All right. I don't know. Let's just go in order. Let's go alpha first. All right, alpha, solving for alpha. We'll try to do this, color coding. All right, now if you look here, looking at the sides of your triangle, I see in reference to alpha, all right, if alpha is the angle that we're going with, 11 is going to be the hypotenuse and 8 is going to be the adjacent. All right, so opposite adjacent hypotenuse goes with the cosine. All right, so the cosine of the angle, which in this case is alpha, equals 8 over 11. Notice how we are looking for that angle. Whenever you are trying to find an angle, when we're using this trigonometry, we want to take the inverse. All right, so we're going to say the inverse cosine of that fraction. The inverse cosine of 8/11ths, that is going to be equal to alpha. All right, now you type that all into your calculator. I don't know that nobody knows what this is. It's a decimal, so this is where we have to type this into our calculator. So the inverse cosine of 8/11ths. All right, that is 43. Then when the nearest hundredth, so 43.34. 43.34. That is alpha. Now, beta. Let's not overcomplicate solving for a beta here. It's a triangle. Think back to what we know about triangles. We know in a triangle, all the angles add up to 180 degrees. The two non-right angles in this triangle are complementary. They have to add up to 90. So if we want to find beta and we already have alpha, just subtract alpha from 90. So 90 minus 43.34 will leave us with beta. Right? So beta is going to be equal to, let's do some mental math here. That is going to be 46.64, I believe. And hopefully that's right. All right, so beta is 46.64. Now, there are 2 ways you could solve for A. All right, we could do some trig, using the answers that we have, or we can just use the Pythagorean theorem. I'm going to stick with that one because let's say I'm doing this. Maybe I messed up on alpha. All right, so maybe I typed in sine when I was supposed to type in cosine. Then if I got this wrong, right? If I got that answer wrong, the answer I got for beta is based off of this incorrect answer. All right, so if I'm trying to use trig to find a, then I would be finding it off an incorrect answer. So a lot of times when I do these problems, I like to use the given information instead of an answer that I got. Right, so I can solve this one using Pythagorean theorem. I can solve it using a squared plus 8 squared equals 11 squared. 8 and 11 are given values, right? So if just in case I got alpha or beta wrong, this I can still get a correct here. Right? So we have a squared plus 64 equals 121. Right? So we're going to have a squared equals, I don't know what that is, 121 minus 64. That gives me 57. All right, so a equals the square root of 57. And I think that does break down, actually. 57 might go into 4, maybe? No, never mind. Maybe 9. 57 divided by 9. Okay, it doesn't. All right, so you just leave it like this. So that is your final answer there. Okay. Now on the next one, let's find C and let's find B. All right. Let's say we want to find B. All right. So if we're looking here, 73 is our angle. We have that 5.25. This is our opposite. This is our adjacent. Here is our hypotenuse. All right. Let's say we're looking for B first. All right. Let's say we're finding B. All right. We have the opposite. We have the adjacent that goes with the tangent. All right. So the tangent now, the tangent of 73 degrees equals 5.25 divided by B. Now B is a variable in the denominator. So you can solve this using a two-step algebra equation, or if you recognize the shortcut, just swap out the tangent with B. All right, so just swap these two values, and we're going to be there. Right, you're going to end up with the same thing. So we know B equals 5.25 divided by the tangent of 73. All right. And again, type that in your calculator. No human being can do that in their head. 5.25 divided by the tangent of 73. That gives you 1.61. 1.61. All right. We can use Pythagorean theorem to find C, but again, then we're relying on that 1.61 being correct if we do that. So let's just play it safe. I'm going to use trig again. Plus, I haven't really done much trig yet for a trig class. So let's see here. We have the opposite and we have the hypotenuse this time. Opposite hypotenuse goes with the sine function. So I'm going to say the sine of 73 degrees equals 5.25 over C. Right? And then same thing, C equals 5.25 divided by the sine of 73. All right, and then punch that in. 5.25 divided by the sine of 73. That gives us 5.49 equals 5.49. All right, and then the last one, I should have done this one first. It doesn't really matter, is beta. Kind of missed it. Beta is just going to be 90 minus a 73. So beta equals, I think that was at 13. No, 13, 17. Beta is going to be 17, right? So here's something we can do just to kind of, play around some math here. 5.49. So this is 5.49. Video is already long, whatever. All right, and then the adjacent we said was 1.61. So if you're ever thinking like, how do I know I have the right answer? Well, let's just think of it like this. We know the smallest side needs to be across from the smallest angle. That side length of 1.61 is across from the 17. All right. The biggest angle is always across from the biggest side. All right. So the 90-degree angle is across from 5.49. That's the biggest side. So your hypotenuse. And then the other side is 5.25. So, I mean, let's just kind of think about this. 73-degree angle. All right. This angle right here, 73 degrees. That's not that much smaller than 90 degrees. All right. So if you compare the side lengths, 5.49 is not that much bigger than 5.25, right? So the closer they are, the closer the angles are in size, the closer those side lengths are going to be. If you look at, you have a 17-degree angle up here, and you have a pretty small side length, right? So 17 is pretty far away from 73. So that 1.61, yeah, that side length is going to be a lot smaller than the other two, right? So that's just another way that you can kind of conceptually confirm that your answers are correct, or at least close. They do make sense for this answer. All right. But let's see, that was page 3. I got one more. Hang in there. I know we're getting long, but one more. You're doing great.